Hi, my name is Matthew Bascom, and this is Graph Factor. This is my XORPD series where I walk you through explanations of XORPD's famous x86 opcode book, Exchange RAX. Let's get started. The XAdd instruction is an operation that performs an atomic exchange and addition. It exchanges the value in the RDX register with the value in the RAX register and then adds the original value of RDX to the value in RAX. This line is significant because the instruction uses implied addressing, where two registers can be exchanged without the need for an intermediary. The exchange operand accumulates the values in RAX and RDX in an atomic manner, meaning that it will not be interrupted by other processes. Each time the loop iterates, the XAdd instruction exchanges and adds the values in RAX and RDX, effectively increasing the value in both RAX and RDX each time. As shown, the loop will continue indefinitely, so I implemented a counter variable in an accompanying script to limit the number of loop iterations. Here we see the XORPD challenge hex 1 starting at line 20 in the assembly program. And in this implementation, I included the ECX register and initialized it to 10. ECX is decremented each iteration of the loop at line 24, and once it reaches 0, the 0 flag is set, and the program exits. To watch the progression of values in RAX and RDX, we're going to compile the assembly program using the NetWide assembler. And link it with GCC. Now, if we execute it, straight away it finishes because it's a pretty small program. So we're going to open it up in GDB. And in GDB, we're going to set a breakpoint at the main loop value. And we're going to run it. And if we look at the registers with info registers, we see that RAX is set initially to 0, RDX is initially set to 1, and we see in the E flags that the 0 flag is initially set. So we're going to continue with C, and we're going to keep our focus on the RAX and RDX registers. And we see that they're initially 1 and 0 still in this first iteration. Now RDX is incremented. Essentially, the value of RAX has moved into RDX, and the new value in RAX was added to the previous RDX, which was 0, so it stayed the same. Now, RAX is incremented because after the swap, both values were 1 and the sum came to 2. Now, RAX was moved into RDX, the value 2, and then the RAX was updated with the old value of RDX being 1, being summed to the new value of RDX being 2 for the value of 3, which was assigned to RAX. If we continue in this progression and we focus on RAX, we see the program exited normally. And if we focus on RAX, the progression we see is 1, 1, 2, 3, 5, 3, 5, 8, 13, 21, 34, which is the Fibonacci sequence. So the loop continues to execute as long as the value in ECX register is greater than 0. Overall, the xadd instruction in the script is crucial to the loop's ability to accurately and atomically accumulate values in the RAX register. That's all for challenge hex 1. See you next time.